cycles that exist in a time series. Very much the same way as a prism breaks down light into its different colors. Here you can identify the cycles, both the long-term cycles, the long-term trends, the seasonal cycles, so that you can use it for understanding a particular series, which is very important. Particularly when it comes to long cycles, spectral analysis is good because it helps you to identify long cycles which are important. Now, for instance, businesses would have long-term cycles, and therefore it is useful from that point of view. So spectral analysis is a method used to identify periodic patterns or cycles in time series by transforming the data from the time domain to the frequency. Now, usually what do we do when we plot data? On the x-axis, we have time. On the y-axis, we have the series. So here in spectral analysis, you convert the x-axis into frequencies. And then you identify. The basic idea of using spectral analysis is to identify business cycles. So business cycles are natural rise and fall of economic growth that occurs over time. They represent fluctuations in economic activity, particularly in measures like GDP, employment, commodity prices, investment, stock market, and production. So we want to find out what are the important cycles, and so that we can use it in our planning. But the only thing that the caution that you should remember is when you identify a long cycle, it does not have to be periodic. For instance, if you identify a cycle of say 4 years, that means every 4 years there's a peak and the next peak comes after 4 years. So it doesn't mean that every 4 years you're going to get a peak. There could be lags. There could be a shortening of these cycles. But generally, what it tries to do is it tells you the cycles. So it's little ambitious for you to model these cycles and try to predict cyclical behavior, which may not yield very fruitful results. Now, the technique that we use is called spectral analysis. So spectral analysis consists of certain steps. The first step, as you all know, first import the data. The data should be evenly spaced. It could be monthly, it could be quarterly, it could be daily, but it may not be very sensible to use daily data because when you're looking at long cycles, daily data does not make that sense. It's better to aggregate the data to monthly, maybe quarterly, depending on your convenience. And a very important thing that you should remember is you must handle missing values, drop them, or you must interpolate them. The second step would be to detrend the data. Spectral analysis does not work when the data has a trend, meaning it should neither be increasing continuously or it should not be decreasing continuously. It should be flat. So if there is a trend, you may have to remove it by differencing, as you already know. That means subtracting the current value from its previous value, or using a moving average and then detrending the moving average, so that the series that you're working with is stationary, does not have a trend. Then the third step is coming into the analysis proper. You apply either a fast Fourier transform or you use a periodogram to convert the time series into the frequency domain. So you must convert the time domain into frequency domain. So you'll be talking in terms of x-axis will be in short cycles, medium cycles, long cycles, right? And you identify the dominant frequencies by looking, when you do spectral analysis, what you get is a spectral density function, which you'll see in the example that I'm going to show you later. The spectral density function identifies peaks, and those peaks correspond to important cycles. When you see the example, you'll understand it better. So 1 by frequency gives you the length. Like if you get a frequency of 0.05, so 1 by 0.05 is 20, and that means there is a 20-month cycle which is predominant, which otherwise you would not know. Because for the formula is 1 by frequency is equal to cycle length, which is in time. Then once you get the periodogram, you get the spectral density or the power spectrum, you plot it. Okay. And use the periodogram. You can use the periodogram also for spectral density estimates. You'll get the spectral density estimates. And looking at the density peaks, you identify the cycles. So the procedure is very easy, though the computation is very involving, which we will not get into in this particular presentation. And then you identify the top frequencies, and the one that is the most important will be the one which is at the highest level. Now, how do Fourier transform convert time domain to frequency domain? The Fourier transform decomposes the time series into sum of sinusoid with sinusoids with different frequencies. So you'll have you'll have very many frequencies. You'll have short frequencies, medium frequencies, long frequencies. And the long frequencies will be on the left side, medium frequencies will be on the middle, and the short frequencies will be on the right side. So each component represents a specific cycle, and you try to find out which are the dominant ones. The fast Fourier transform function computes the amplitude and the phase of the sinusoids, allowing us to assess the frequencies dominate which frequencies dominate the series. So when you use instead of fast Fourier transform, if you use a periodogram, then how does a periodogram convert to frequency domain? The periodogram estimates the power of each frequency component in a time series. It is essentially the squared magnitude of a discrete Fourier transform normalized by the number of observations. It helps to identify the most significant cyclical pattern by measuring their strengths across the spectrum. So what spectral analysis does is it calculates a spectral density function, and the spectral density function tells you which of the many frequencies that you're entertaining contributes most to the variance of the series. Then once the peaks have been identified, then you interpret the results. Identify which are the dominant peaks, which are the ones that correspond to the strongest periodicities, and you can convert the frequencies into cycles because you'll understand it better, and it's easy for interpretation. And finally, you will interpret the results, right? Okay. Now, in summary, first clean the data. You use pandas. Detrend it, either use differencing or you can use rolling means. Apply Fourier's transform. The command is a numpy. This thing, it is np.fft.fft open and bracket. Give the series. Of course, it should be detrended. Compute the power spectrum, which is nothing but the absolute np.absolute of that particular output. You square it. Plot the power spectrum using matplotlib and interpret the frequencies and identify the ones which are the biggest frequencies. So we don't stop there. We're just being a little adventurous, may not be the right thing to do. Once we've identified one important cycle or two very important cycles, you can try to model it. Because merely identifying the cycle will not be very useful unless we can model it and use it and forecast it. Like for instance, we want to know if the stock market is going up and down, when is the next peak going to happen? When is the stock market going to be? Like a word of caution, you should remember that the cyclical variation does not repeat periodically, but it's just indicative. It's something only to guide us. It's not something that we're going to use it very rigorously. I mean, just to. So in a harmonic analysis, which is the next thing. So first, in the first step, you identify the cycles. Now, let's say assume you've identified a 36-month cycle. Then you construct this value. Yt is equal to, that is your series you're going to study. So you take sine 2 pi is 180 into 1 by 36 into t plus v2 into cos 2 into 180 divided by 36 into t. So t goes on taking values 1, 2, 3, 4, 5, and it goes on increasing. Supposing you have two cycles, supposing this is okay. This is a classification of the same thing. It's just to put a square. There's no difference between two. If you have multiple frequencies, then you should have more pairs of sines and cosines. So like you have, look, you can see there is a k over here. So you'll have the frequency of the first cycle, sine and cos, plus the frequency of the second cycle with sine and cos. So essentially a harmonic analysis is a combination of sine and cos functions with the periodicity coefficient over here. So we have more periodicities, you can just extend this and you will get a harmonic analysis with more frequencies. So that with that presentation, we will go straight into the analysis. And what I thought was, instead of using a better illustration, I have taken the Bombay Stock Exchange index from 1979 till 2023, I think 2024 mid. I've taken a long series. It's a long series. I can share it with you when I share you the codes. And I'm going to run the spectral analysis code just as I explained it to you. Please recollect what I said. First, we import these general packages which we always do when we work with Python. Pandas is for manipulating numbers. NumPy is for, no, sorry, Panda is for importing data. NumPy is to manipulate the data. Matplotlib is to graph it, and OS is to set the path. So I'm going to set the path, Python learn. I've got a folder called data. So my file is over there. And there I'll pick up this data called BSE historical. And then I'm interested only in the date and in the this thing. I'm interested only in the date and in the this thing. So I'll just show you. What it looks like. I'll just show you the first two rows, what it looks like. So because there's no data here, they don't know open high. So I just want the 0 and the 0, 1, 2, 3, 4. So I'm taking only 0 and 4. Then I'm looking at it over here. I don't want to look at it. I don't want to make it very too long. I'm looking at this first two rows. That's the thing. That's it. Yeah. Then I have to convert this into a date format. If you've seen my earlier videos, you'll understand. pd.to underscore date time. Since the format is not sure, I say format is mixed. And now when I look at the info, it tells me that the date is in the date format. And I wrote in the very beginning, first class on introduction to time series that it's absolute must that in any time series data, there should be a column which indexes the date. It could be year, it could be something, and it should be in chronological pattern. Okay. So then what I do is now I told you, we discussed this also in an earlier class. Sometimes gaps could occur in the data because of holidays, not filling the data properly, which you will never know because when the series is very long, you can't be examining the data. So I've gone to ChatGPT and told it, look, this data, the stock market works only 5 days in a week. We talked about this earlier. So it only works 5 days in a week. So I use this frequency B rather than frequency. Otherwise, Python will assume that there are 7 days in a week, and then Tuesday and Wednesday become Saturday and Sunday, and the whole series gets distorted in a way. So in order to cover that, I do this, and then I convert this into an index, right? So now it's done it. Look, there is a day, there's a holiday on 5/4, there is no data, it builds it up, and it gives you a continuous series 3, 4, 5, 6, 7, 8, 9. So this is very important if you're very particular that your data is absolutely perfect. Okay, then what I do, I have to look at the shape and see, look, what is the shape of the series? It has got 11,419 rows. It's daily data starting from 1979, which means you're talking of before Harshad Mehta's scam. Harshad Mehta's scam came in 1982. Sorry, 1992, yeah. So this is a long series from the Bombay Stock Exchange. I've got it from the BSE website, right? I'm now going to check whether there are any missing values because I've interpolated the data. No? So out of 1,375 days, because it's a very long series. There could be holidays, there could be Saturdays, holidays, not Saturdays. Saturdays are already taken care of. Then what I tell the computer is interpolate. So it is name of the file is df, interpolate, in places equal to true is to ensure that the interpolation remains for the rest of the session. Then I go back and check, has it interpolated all the values? I do an isNull.sum, and I find that there are no missing values. All the missing values have been filled up. Therefore, now I'm going to take a plot of this series, which is called sensex. So I'm going to get a plot of the series, and I notice that sensex has been very flat up to 1990. This is Harshad Mehta's time. And then it went up, and during Corona it came down, and it is going up. Now I want to find out what are the cycles of the series. My objective of this exercise is I want to find out what are the cycles in the series. So what I do is I convert it into monthly data. How do I do it? You're already familiar. Give it a new names, df_m. Df is the name of file. Resample m. And I want the last value. I don't want the mean for the week. I want the last value. That means the last value of the week. So I'll get the Friday's value. Okay. And then now I'll plot this m_m. Okay. I should plot them actually. So I plot this underscore n. Now this is the monthly data. This is the monthly data. It's a little shorter series, but looks quite presentable. Now what I do is now I'm going to pick that periodogram. I told you, I'm going to pick the periodogram. I take the series ds underscore ilog is equal to the 0th column because I want first column because there only one. The date has gone into the index. The date has gone into the index. As you see, it's not showing over here. Okay, the date has gone into the index, and that is why I'm telling the computer, give me only the zeroth row. Okay, in case you want to see it. In case you want to see what it looks like, that's it. Data is in the index. Therefore, I'm telling the computer, just take the zeroth column value, right? And then do a frequency periodogram directly. Now, this series is called series. I called it series. You can see that. Now, this is my original data. I've taken the first column and I call it series. And it's going to fit a spectrum and all that. You can see these codes. And then I will just show you what it does. Now, the thing I told you about the analysis when I started was the series has to be stationary. Now, one look at the series, you know the series is not stationary. So it has obviously it has to be made stationary. And if it's not made stationary, you can't identify anything. Except it shows an exponential decline. So you're not able to identify any cycle. So please remember, whenever a series has a trend, as you can see over here, the series has a trend, you have to either use a moving average and remove the trend, or you have to do first differences. So now I've done the same thing. I've done the first differences. Now I'm not going to use series. I'm going to use series dip. And I'm going to run this whole command. You can study the command because it's available in ChatGPT. You could easily get it in ChatGPT. There is no problem. And there you go. Now, this is my spectral density function. This is my frequency. From this, I know that this is my most important frequency, which corresponds to maybe 0.28. So I want to know what does that peak corresponds to. 1 divided by 0.28 will give me a frequency value of 3.5 months. So what it says is 3.5 month cycle is the most important. It's a seasonal cycle, obviously a seasonal cycle. So stock market has a predominant 3.5 people. All the long cycles are on this side. So please remember, all the long cycles are on this side. All the short cycles are on this side. So you have a long cycle over here corresponding to I do not know what. So what you do is you just go and tell ChatGPT, please identify the important cycles. So I get it from ChatGPT, he gets me, and he says 0.29. I says, please convert it into frequency. It says that corresponds to 3.41. Then I said, no, I don't want that. Give me 5. Give me at least 5 important peaks. And then I asked to convert it into time domain. Now I'm going to convert this frequency into time domain. I use periods, 1 by non-zero frequencies, and then it converts into time domain. And now this is understandable. This is not understandable because it's in frequency domain. So I've converted it into time domain. And now from this, I can straight away make out that the predominant cycle is the one that corresponds to about 41 months. That's good enough for me. Look, it increases this way. There are a lot of short cycles also. I'm not getting it. There's a 20-month cycle also. You can see there's a 20-month cycle. There is a 43-month cycle. And then I tell the computer, please identify them. Because why should I do it? ChatGPT will do it later for you. And they say the dominant frequency is 43.75 months. Now, 43.75 months is how much? 43.75 divided by 12 will give you actually it works as a 3.664 a year cycle. So the Bombay Stock Exchange or any stock, National Exchange, Stock Exchange also behaves the same way. It has a tendency to peak every the 3.6 years and then go up. It'll go to from now. If it's up, it'll go down and then come up. By the time it reaches the peak, it'll be 3.6, and then it'll go down and come up, it'll be 3.6. Now, if you analyze the data, stock market data very closely with a little bit of empirical understanding of what happened since 1981, you'll notice that actually the stock market cycles are on about 6 years. You may wonder why is it only 3.6? Now, 3.6 years may be a part of a 6-year cycle or a 7-year cycle. Now, 7-year cycle is not visible because your data is from 2024 till 1979. Say 45 plus 1, 46 into 12. So your data has got only 552. I've identified my cycle. This is my cycle. 43.7 months is my cycle. Now remember what I showed you. I will now substitute it into this equation. 1 divided by 43.75, And the values will take 1, 2, 3, 4. I've generated that. So here's my data. DFM is, we'll call it DFM itself, what we originally. This is my dominant frequency, which is 1 by 43.75. Okay, my dominant frequency, here it is. And now you can see there is a sine wave and a cos wave. And since the series is increasing, I've added a trend component also. Okay, because I'm going to fit it to the original data, not to the series. Series is the one which is corrected. Right. Then what I do is I'll run it like a regression. I'll generate the data here, run it like a regression, and we will get the results later. Now, you know, the important thing in spectral analysis is to identify the peak cycle. The peak cycle has been found out at 43.75, which is roughly 43.75 divided by 12. Okay, which is roughly a 3.64 year cycle. That means the Bombay Stock Exchange has a tendency to repeat from one peak to another. It takes about 3.5 years, a little more than that. So this is my harmonic function. There's a trend, significant. There's a sine wave, which is significant, a cos wave, which is significant. Now, I've also asked it to plot it. So you can study these codes carefully. I've asked it to plot it. So with the series, it is plotted this harmonic. It will not coincide, mainly because you have not included all the cycles. You know, our analysis has identified many cycles over here. And as I identified many cycles, these are all very short cycles, which I have not incorporated. I've taken only a long cycle, and there's a very long cycle here, which must be around this must be around 80. This must be about close to, not exactly 90, it will be about 88 months. That's not important, but it's still there. So 88 months divided by 12. You see, 7 years. That's what I was telling you. That's what I was telling you in the beginning. You know, it's not important, but it's very much there. So if you're really looking at a long cycle, it's really about I just said about 80, about 7. You know, let's say could be about 7 years. I told you about 6 or 7 years. So these are cycles which you cannot either identify normally without. So now I've modeled it and put only that one cycle, and I wanted to see that one cycle. And we roughly look. No, it's picking up the peak here. It's picked up the peak here. It has not really captured a peak, but it's captured a trough over here. It's again captured the creep over here. Then what I told is I went into ChatGPT and said, please forecast it for the next 10 years. Right. I said, please forecast it for the next 10 years. So all these codes, you don't have to worry. You can get it straight away. Only thing you have to tweak it a little bit when it doesn't run. And then I find that this is what I get. This is where the series ends. And then what it says is, we are going to get a peak in 2026. Recently, in a newspaper item, there was an article that the markets will peak by 2026. So from now onwards, we are here in 2025. From now onwards, the market will continue to rise as per this. But please remember, word of caution, the periods are not periodic. They don't repeat at regular intervals, like I'm seeing over here. I'm just being a little ambitious, just to show how these cycles behave and what inference you can make. So what you say is, there is a peak in 2026, and then it will come down after 26, and markets will come down. In 2020, between 2027 and 28, the markets will be at its bottom, and then it will start peaking again in the year 2030, 2029, 2029, 30. That's, that these are some geopolitical events will take place. And this is how spectral analysis is used to identify cycles in time series data.